Good to go?
All right. So my name is Robert Mosley. I've worked with a lot of these people around here in the past. I'm an ex-Chesapeaker, so I was out at Chesapeake for 9 years. Did a lot of data warehousing at first, then I moved over to the SAP project. I was a data strategist on the SAP project, so a lot of data conversions activities. Moved from there a little bit into data science, doing a lot of data governance. I was sort of the product owner as we moved our warehouse from Oracle to Snowflake. We had Databricks as a sort of a small presence at Chesapeake. I had a desire to move more into the ML space. I was doing as I said, the governance stuff, data warehousing, things like that. I ended up leaving Chesapeake during the bankruptcy and moved over to Enable, which is close to here. And so I was there for about 3 or 4 months before they sold to Energy Transfer. And so things sort of really slowed down. Hi, Misty. How are you? Things really slowed down over there. I decided after going through a bankruptcy at Chesapeake and going through a sale at at Enable, I decided I needed to step outside of the energy space a little bit. With COVID and everything, my horizons felt like they had really opened up, so I started exploring a lot of different options outside of Oklahoma. I ended up landing at Databricks. I started there last June, so a year ago, so 15 months or so. And it's been a really good transition for me. Databricks has been pushing a lot into the data warehousing space, the data governance space, with a lot of its recent products, and so I'm able to add value there, but I'm also able to learn a lot about the ML space and everything. As it so happened, I mean, like many of us, right, we like to tinker, do stuff on the weekends, other times. What I had been exploring more recently was doing some Twitter downloads, getting a lot of tweets, a lot of profiles, trying to do some NLP around it. So it's natural language processing is what that refers to. For anybody in this space, you're going to be familiar with that. I was largely unsuccessful with what I was trying to do. I started exploring OpenAI's models and had a lot more success. So a lot of their DaVinci, their Ada, I think it's called Babbage or Cabbage or something like that. They have several. I think they would call them like the 3.0 type models, different sizes. Doing some fine tuning with that exercise. Getting good performance out of those models, and so I was really enjoying that experience. Then ChatGPT 3.5 came out, right, and that started a whole new storm around this concept of generative AI. You had things like picture generation and stuff, and people found that neat, but ChatGPT started opening people's eyes to what could be there. Because I already had a dev account with OpenAI, I was able to get like beta access to 4.0, and I was able to start trying a lot more things against these endpoints. As it so turned out, companies cared a lot about this technology, and they really wanted to jump in and explore it. And I guess people playing around with LLMs wasn't really a thing a year and a half ago, and so. With that experience that I had in it, all of a sudden I became the manufacturing expert in Databricks on this subject. So I've sort of, as it is an interest of mine, I've gone full tilt into it. I now talk to companies on a very regular basis. I have another meeting this afternoon that's going to be around LLMs I don't know how much I should name names if I'm on tape, but I did a workshop for a major oil and gas producer in Houston last week. I do sessions literally all the time, 4 or 5 times a week, helping companies explore this topic, because as we'll get into it, LLMs are great at writing haikus or helping your kids with their homework or helping you phrase an email a certain way, but they're really bad at performing on your company's domain. One example that I give in oil and gas is if you were to ask ChatGPT about pigs, it's going to answer you about animals when you might be asking about pigging a pipeline. And so it's not going to know that area extremely well. And if it even starts to understand what you're asking about, it may start hallucinating. That's a concept that I think most people have heard about these days, but the idea that an LLM is really trained to have an answer, not necessarily to have the correct answer. And so when it hallucinates, it's actually making stuff up on the spot, and it's really good at doing that and being convincing for your audience so that they think maybe it actually knows what it's talking about. My favorite part about that is when you're trying to ask it to generate code. If it's not possible to do something, it'll still generate code as if it is possible to do something. And then when you run the code, it'll break. You'll tell it that it's broken. It'll hallucinate a whole nother thing. You'll run that. It'll break. And so you can spend lots of cycles dealing with hallucinations from an LLM before you finally realize, it's just not possible to do what I'm trying to do. Anyway, so I got that little background out. I have a few slides here just to talk through LLMs. I'm going to stay away from a lot of the salesy slides that I'm used to showing. But this sort of sets up LLMs. Hopefully many of you have heard of this subject and are aware that there's a lot of activity around here and what kind of buzz it creates. McKinsey released a report saying that generative AI's impact on productivity could add trillions to the global economy. And I view generative AI, years past, you might have heard like blockchain and things like that, and there are certain buzzwords that flow in the tech space. Gen AI, to me, is fundamentally different. It's more like the internet, which I think I have another slide on right about here. So it's fundamentally different because it actually can grow and expand and continue to add productivity. So the idea here is that innovations don't become technology revolutions until they're democratized, until they're in the hands of the masses. So you can look at that from computing, internet, and now generative AI with like the deep learning space. Computers were around for decades, and while they did help certain things like NASA and major corporations, until it became a PC, that's when you saw Microsoft and Dell and all these other companies really come up out from nowhere and scale and become that technology revolution, getting it into the hands of everyday people. And I forgot to mention Apple, of course. Then the internet, right? It was at universities. It was sort of a neat way to share information until the browser came in and landed on people's PCs, and AOL started giving people access to the internet. And then you had the dot-com boom, right? And it took a full decade. And similar to that, I think we're in a new space. It took us about a decade to figure out what to do with the internet and where directions we're going to go. And we're having that same type of moment now with AI, whereas AI used to be a very specialized task, especially deep learning type activities. Just a few people used it. They could use it very powerfully, but it wasn't in the hands of everyday people. We're starting to see generative AI models in the hands of everyday people, being able to fundamentally change how they approach their work and their day-to-day lives. And in the same way, I bet that 10 years from now, we'll look back and be like, man, we barely knew what we were doing. And it's so much more further developed. So this is, Gen AI space is being very much driven by LLMs, so large language models. What we saw was ChatGPT being released last November. I think it was November 31st, right? The last day in November, so almost a year ago. And then you saw sort of rapid advancement, one in open source, but also with like Bard and Google trying to catch up a little bit. You saw ChatGPT, bring out 4.0 to outdo itself. What I do note here is DALL-E in the middle. That's Databricks' contribution to the open source community. So at that time, there were a lot of open source models that existed, like Llama, Alpaca, and others, but they were mostly for research. Their licenses did not allow people to use them commercially. And so what Databricks wanted to do was release a model and show what could be possible with a commercial license for a model. So we actually took an open source model that was out there. It was non-instruction based, and then we applied instruction-based data sets to it, fine-tuned the model, and created Dolly, which was an instruction-based fine-tuned model, had pretty good performance for its size, and we released it out there. A lot of people then looked at us as like, hey, you guys have this new product, you're trying to enter the foray. Dolly was never meant to be a product. It was more of a proof of concept. If you think of it, sometimes Google releases hardware to show other companies how hardware should be done, with their operating systems and things. And so they'll release a computer, and then they'll discontinue that a couple of years later, really trying to advance things in that space. And it largely worked. After we released Dolly, you saw a rapid advancement and releasing of commercially viable LLMs on the market. So if you've had the chance to work with any of them, you might have heard of Mosaic's models, MPT models, the Falcon models. We ultimately acquired Mosaic ML, and so those models are technically part of our products. And then also Llama 2 was a big model that was released. Since then, there's actually like a Falcon 180B that's been released, and it proves to be better than ChatGPT 3.5, not quite as good as 4.0. What you start to see with that is a 180B model is very expensive to host, and so it's used less often than Llama 2. Llama 2, the largest model you can get is 70B, which stands for 70 billion parameters. ChatGPT 3.5, I think, is 220 billion parameters. So Falcon at 180B, outperforming ChatGPT 3.5 is significant, but it's still too large for most people to just spin up a cluster and begin to host it. But you do see a lot of people using the Llama 2 models, and that, to me, is what on the open source side, is probably the most popular model that exists out there.
What's the smallest, the Llama 2?
It's 7 billion, so 7B. And the demo that hopefully I'll be able to show you guys, it wasn't working this morning, but the demo that I'll show you guys is a 13B model. And so I'll be able to show that to you guys, or hopefully. I've been talking to someone, a developer who's working on it. It's a Hugging Face problem, not a nothing else problem, but if I can't get the Hugging Face part to work, then I can't get it to work. So, sometimes this is a lot of times what I start with people, especially in companies that don't have expertise in deep learning in AI. How do I compete in an AI world? I think for the first time, white collar workers are suddenly like, hey, will this impact my job? Will this take over my job? If it can do all this stuff so well, what good am I for? And so then companies start wondering, what are the threats to our company? Can someone with LLMs, use AI to suddenly enter our space and unseat us because we're in the past? We're not using AI. So a lot of people want to make sure they at least spin up this capability. A lot of times the questions are, what model should I use? Worried about ChatGPT or whatever. A lot of times I'll tell them, hey, don't focus on the model. That's not your focus right now. A lot of times I say the model you use today probably isn't the model you use tomorrow, won't be the model you use 5 years from now. Even the model you start with in a project may not be the model you release the project with. And we can get into whys and stuff like that. What I tell people to focus on is their data. The reason for this is that models are quickly commoditized. Even if somebody does come up with something better, they release it to everyone. Everybody has access to that same model. Nobody is differentiated with their model in that regard. You have lots of open source provisions that are catching up to the SaaS models. GPT-4 definitely still has the advantage, and it's the leader. There's a lot of talk about Google's Gemini and what that'll do. And I think you're going to continue to see people learning to build better models that are smaller so that they're more accessible to people. But what is true is, as we talked about before, these models that are released while they're trained on the general internet and they have lots of subject areas under their belt, they can talk to you about the Roman Empire, and they can talk to you about the mole on your skin, and they can talk to you about some technology that was released 5 years ago. They can't talk to you about your business's data that's specific to your industry. And it's because you have that data. It's proprietary, and that model hasn't had access to that. So only you has your data. Therefore, only you can build the Gen AI applications that involve your data. And so the moat that you actually have is your data, not the model itself. And so you can quickly add in any models that are released on the market, and as long as you have that moat of your data, you'll be able to build applications that no one else can. And so your data ends up being really critical there. So taking a look at this, just emphasizing the fact that Gen AI apps need more than just the model. At first, you might start asking that question: why should I use, or what model should I use? A SaaS model. And when I say SaaS, it's like OpenAI or Bard, somebody that you're sending the request to, they're processing it and sending the answer back, versus like an OSS model, or build your own even. With Mosaic, we have the offerings where we allow companies to actually build their own models from the ground up on only their data. Definitely more advanced, but you might be asking yourself, where should I go in that space? But very quickly you start asking yourself, okay, what data do I combine with that model? Is it encoded correctly? Have I put it in a vector database? Things like that. Is my app generating correct and safe content, or is it hallucinating a lot? And then lastly, as I start to scale this, is it available? Can I scale it? These questions have a lot more to do than just models. It has to do with your data, your operations, a full pipeline of product that you're going to have to incorporate. And so as we look at LLM ops as sort of a subspace of ML ops, what you realize quickly is you need a whole platform. Now this is probably my most salesy slide that I'm going to show, and then I'll back away from here. So Databricks is that platform. We were originally founded on AI. I think everybody knows us in the AI space. We have quickly, the founders quickly realized that AI is nothing without data, and so expanding that platform so that it encompasses a lot of your data needs, from data warehousing to data streaming to orchestration, all those capabilities that you need to be able to ingest, manage, transform your data for AI have been added into the platform. And so we call that the lake house, the combination of data warehousing and a data lake. And it becomes one platform to be able to merge all those spaces together. It makes us perfectly suitable for Gen AI. I've removed these slides that talk about it, but what you saw with customers is that they immediately started, when all this stuff hit, even before we had released LLM specific features, customers were ramping up their usage of LLMs on Databricks because it was always fundamentally something that you could do. And probably the only platform that you could easily do it on. Most other competitors have had to start adding those capabilities and scramble to get there because they see that this is a space that's there. We are already there. So we are adding new features to make it easier to use, but our platform was already capable of handling those types of activities. So these are the patterns, and this is what I'm going to spend most of my time talking about today, is going through these patterns. You could start very easily just, hey, I want to interact with my data. I won't talk about our products that we have with that, but that might be just like asking questions and letting a process interrogate your data and give you answers. Another one could be combining your data with an LLM. So we're going to talk about it, but the concept of a RAG architecture. Has anyone in here heard of RAG before? All right, we got 2 hands. So I will, yeah. Retrieval augmented generation, which helps no one. And so we'll talk about what it actually is, but it's about taking data and merging it along LLMs so that LLMs become better, and they hallucinate less, and they can answer your questions. And it requires no fine tuning. which is really the best selling point. It's usually pretty easy to do, and you see some good results. So it's a way to add value and show value very quickly. Fine-tuning models, so this comes down to either specific use cases or somebody trying to embed domain knowledge into a model. That's actually a very tricky thing to do. We'll cover that as well. All the way to building your own from the ground up. We won't really dive into that so much. It's sort of like a superset of that fine-tuning a model, but we offer that with Mosaic ML to be able to do that. Once again, I won't mention the company since I'm being recorded, but maybe a company that either does a lot of scientific research and they have lots of scientific papers. They can train a model solely on that information so that it knows that kind of thing. One of the great side effects of building your own model from the ground up is you don't have to really worry about it replying with inappropriate content because it hasn't even seen Reddit or the dark edges of the internet, so it doesn't even know how to insult someone. And so you have to worry less about the safety thing because it's only going to reply in the manner of the data it's been trained on. So this gets into LLM solution architecture, and this is my favorite thing to talk about. As you can tell, the slides changed. I merged two slide decks. So this is what we think of when we think of interacting with ChatGPT. Somebody sends a prompt and it gets a response. It's really slick, really clean, really easy. As we said, it's good for broad general application. It's not good at your data. So this is where people most often go. They go, okay, that means I need to fine tune the model. They think like traditional models, you got to train the model. They think, okay, I got to train the LLM on my data. And so they step into fine tuning. This is actually, so these types of activities are supported by OpenAI. On 3.5, I don't think they've released it for 4 yet, but they supported it for all their older models. It's the type of activities that I would do with it. It's a great way to teach a new skill to an LLM or to teach it how to respond to something. So say you're trying to build a model that will write your emails, or you want it to reply in a certain JSON format. Really easy to fine-tune the model on a set of examples, and it'll learn what you're trying to do, and it'll be able to handle those requests and be much more accurate in the future. Did we have a question? No? Okay, sorry. And if we have questions, feel free to raise your hand. So this is great for that type of thing. What people always want is they say, hey, I have tons of information on how to drill a well. How do I fine tune a model so that I can interact with it and it'll know how to drill a well? That's actually very difficult to do. And it's possible, but you're not going to just approach it in a weekend and get a solution. The difference between fine tuning and what we'll talk about with RAG is that fine tuning, you got to approach it less like, hey, I'm going to give someone a book and have them read that book, and more like, I'm going to send a student to a 7-year PhD program. The model needs to see lots of data, a wide variety of that data, the same information told multiple different ways for it to start to actually represent that information well. If you'll understand LLMs at their core, their goal is not to actually learn anything. Their goal is a completion engine. Just like on your phone, when you're clicking that autocomplete on that button, that's all it's doing is it's predicting the next word in the sentence and giving it to you. And so because of that, you can't give it a one-shot learn and expect it to actually ingest that information and know how to answer a question about it. It's just going to do predictive text on anything that you ask it. GPT-4, 3.5, these models that are really capable, it's astounding because it does feel like they have real knowledge in them, but at the end of the day, it's a completion engine, and that's what's going on with it. And so to do that does take time, does take effort. It would take a thing. You probably won't be successful the first time you try it. And so that's why if your goal is to embed your domain information with the model, I recommend using RAG. And I don't know if you guys can see that. Yeah, that made it worse. So RAG retrieval augmented generation, or as I will often call it, context stuffing. So what this comes down to is adding additional information in the prompt to the LLM so that the LLM can better answer the question. It's very complicated. When you say retrieval augmented generation, it's very simple in practice. What you do is you have a catalog of information, maybe information about your well and how to drill a well, and you break it up into various chunks of information, and you stick it in a vector database. And so that actually uses another LLM to create embeddings, and you store it in that vector database. When you do that, there's a concept called a similarity search. So what happens is somebody asks a question like, hey, what kind of lateral length should I use in the Texas Permian Basin? I don't know, maybe they asked that question, right? That prompt comes in, and it's not received by the LLM, it's received by an orchestrator tool. And all it does is it says, hey, do a similarity search. So this is the question, do a similarity search. What happens is it creates embeddings, those types of tokens for the LLM, and it does a lookup against that vector database, and it finds chunks of information that are related to lateral lengths in the Permian Basin. And it'll find those documents, and then it includes that into the prompt. So you'll use like a prompt template. And now what the prompt looks like is its instruction, context, and then the actual prompt that was submitted by the user. So now it says something like, instruction might be, answer the question using the information below for the question that's listed below that. And you might even include in that instruction, if the question doesn't pertain to any of this information, then simply reply with, I don't know the answer. And so that's one way to sort of fight off the hallucination concept. And then you send that whole prompt to the LLM. So now the LLM has not only the question, what kind of lateral length do I use in the Permian Basin, but now it has additional pieces of information about lateral lengths in the Permian Basin and whatever else it can collect. And then it'll read all that content, and it does a really good job of giving you an English answer in response. Yes?
Is the LLM at that point just a summary?
It is sort of like a summarization engine. I mean, the goal is for it to be able to give you, an educated answer. And in the demo that I'll show you, we create a RAG around chemical information, for instance. And so it's like you can ask it, what do I do if I get acetone on my skin? And I'll tell you, you need to go wash your hands and things like that. What happens if I ingest arsenic? Call this number right away, seek medical attention, things like that. And so it does somewhat summarize the text. So if before, go on.
So the answers that we are getting, is it directly from the document? It is directly from the document, right? It's not outside.
That's the goal. That's why you might include like a sentence that says, if the context doesn't answer the question, then say, I don't know. Because at the end of the day, LLMs are usually trained to give you an answer. And so if it doesn't know the answer, and if the information is not related to the question, so say I have this chemical database that it's looking up against, and I ask it about a TV show, that naturally an LLM is going to give you an answer, and it'll hallucinate and make it up, even if you're looking up that information. So that's why it's good to do some of that prompt engineering in the instructions to make sure that it doesn't do that.
Okay, so we set that up, like the prompt engineering that what you're doing. If there is no answer, just say there is.
Yeah, and so that would be that instruction line, so that would be part of the prompt template that you would create.
And the vector database there in that second step, is it all a set of documents? Is it like a folder? Like how does it take the data?
So that's where that pipeline comes in. And so this is a lot easier to do because when you're fine tuning, you usually need to get your data in a certain format, highly cleaned. I have a solution accelerator where we just download a bunch of Spark documentation off the web. We chunk it out. So what that phrase means is you don't want to have just these huge masses of information where it only matches on like a sentence, right? So you create chunks where you break it up into paragraphs or whatever. And then you store each of those paragraphs as a separate entry into the vector database. So it is an ingestion pipeline that you got to build. So you ingest those documents, whether it's Word doc or HTML or PDF. You break it up, and then we have our own vector database that we're releasing. But if you just store it in a table, like a Delta table, and you have a string column, you just point at that column, you tell it which embedding library you want to use, and it generates the embeddings and stores them in a vector database for you. If not, you got to do that yourself. So there are lots of open source vector databases out there, like Pinecone, Phase, or Phise, depending on how you pronounce it. Chroma is another one. Melvis, or Melvis, I think. Melvis has a lot of contributors from China, so that's been fun talking to companies about that because they're worried about China stealing their data. So you know, but Melvis is actually very well architected too. So, but yeah, so there's lots of open source databases, and you gotta engineer it a little bit like that. But LangChain builds a lot of libraries to make it more straightforward, and so you just point it to a model, and you point it at the target, and you have a script that'll generate those embeddings for you and stick it in the database.
So basically, the first step would be like we have to clean the data in order to get.
Yeah, you have to get the data. Like I'm working with someone right now on a proof of concept, and what they do is they have a ton of contracts, legal contracts, and they're 40 to 50 pages long. And they're ingesting that in, and they've broken it out by clause. And so they have a single table that has each clause broken out in it. And what we'll do is we'll create embeddings off of those individual clauses, and then we'll interact with the database like that. So you do need to ingest it and get the chunks that you want, but you'll get surprisingly good results on some just very simple chunking strategies. So you don't have to spend a ton of time with it. You'll be really surprised by the types of results that you get from it. Almost everybody who starts with a RAG architecture, as I said, it's a great way to show value early on. My comparison earlier with fine-tuning, sending someone to college for 7 years to get a PhD, RAG is like having a really smart intern that knows how to use Google really well. And so you can ask them questions and they can give you some good answers. It doesn't have fundamental understanding of the background. And so that's when you'll start to realize it has some gaps. If you start asking it, you know, real in-depth or large strategic type questions, it's going to struggle with that. But if you're asking it very specific type questions, it'll do a really good job of answering that.
Do you have a favorite model you like to use for embeddings, and then same on the LLM for like a POC, like
yeah.
to see get it working?
As I said, you get surprisingly good results when you start with RAG. So I haven't spent a whole lot of time like trialing and erroring different vector, different similarity search stuff.
Yeah.
As he's talking about, you can use a different LLM for your vector search than you do for your actual model down here. And the example that I'll show you guys here actually does that. It has different models. There are models on Hugging Face that are specific to the vector database type activities, and you'll have people ask you all sorts of questions about different algorithms for that similarity search and everything. As I said, usually early on you have really good results, and so those are sort of those incremental adjustments that you can make to improve. Also looking at how do I chunk out this text to make it more make it better in the resulting results.
One last question.
No problem.
So in Snowflake Streamlit, I've not used it, but I think I've read that we can just give the document. It reads the document and you can ask certain questions and it will answer.
Mm-hmm.
So this is completely different from that, right?
I mean, it's somewhat different. You could, for instance, stuff the entire document in there, or you can retrieve documents ad hoc and then ask questions of it. You always have to worry about your token limits. So, you know, GPT-4 naturally has a 4,000 token limit. Is everybody here comfortable with the concept of a token? So a token is a segment of a word. I usually compare it to syllables because that tends to be how it's broken out, is very similar like that. So when you have 4,000 tokens, that could be 2,000 words that you can work with inside a single call. And so if you're working with a long document, you're going to run out of tokens. GPT or OpenAI does have a 32,000 token version. I myself haven't been able to get access to it. It is somewhat restricted. I think if you're a company, you can apply for it and get it. That's, it's 32,000 tokens, and it's a more expensive model, so you're going to rack up costs. But they charge you per token. And so usually you don't notice the cost when you're just prototyping and playing around with things. When you scale it, that's when you notice the costs. We had a customer that built out a solution, a chat bot, and when they rolled it out to their customers, they were looking at $25 million a year in token costs. And so they came to us to build a model that could do very similar things for a lot cheaper. And so those are the types of things that customers a lot of times are like, I'll just use OpenAI for everything, until they start to scale their solutions, and then they go, oh man, we need to come up with a different strategy for some of this. And so it can get expensive after a while.
Let's say that I actually want to figure out the optimized natural language programming wells. Where would I get the source data to train those data from? The only source I can think of is drilling info and various public data. So how can you like download and train those in and feed it into that model you're talking about?
Yeah, so in this solution, I do want to harp on the fact that we're not actually training anything, right? So we're just downloading the information, putting it in a vector database, and we're providing that information at inference time for the model to be able to read that information and give a summary. So that is that moat, right? That data moat. So when you get into critical applications for your business, like how to drill a well, one, this is going to shine a spotlight on companies' data management practices, but also it's going to show who has their data and who has proprietary information and who does not. So the requirement there is that you as a company have information on how to drill wells, and you've documented this, and you have, maybe you have, reams of information about it. Maybe you don't. Maybe you do, but it's scattered all over and you haven't managed it well. And so now you have some legwork to do to get all that stuff collected into a place. So if a company has had good data management, good data governance practices, they probably know where this data is already. And they can go and all they have to do is build the pipeline to ingest it. If they don't have that information available, or if they don't have those practices, then they've either got to create it or they got to find it to be able to work with it. And so that's if they haven't been doing that already. So the idea would be if you have engineers that have written up tons of reports on the Permian Basin and how they've drilled it, and good and best practices and bad practices and things like that, if they have that information cataloged out there, all you got to do is point to that directory, ingest it in, chunk it out, provide some metadata with it, and put it in the database, and then you can do your similarity search with it. So if the data is ready, I can build this out in an afternoon. If the data is not ready, then you got some data prep work that you got to do. But even if that data is just sitting out there in a directory, I've built a script that will grab like 32 different type of file types and ingest it in. And it auto chunks it, and so it gives you something to play with right away. If you don't have that information available, that's where it gets troublesome.
You said you're not trained with any liquid data. I thought whenever you provide new data, you have to train the model.
So if you're fine-tuning the model, you do, right? So that's what this would be. You'd have to get that model, and then you'd have to do a fine-tuning application on that. With this one, all you're doing is providing extra information to the LLM at runtime. Does that make sense? So it basically takes the prompt that you would normally send to ChatGPT and now supplies it with a lot of related information to your question. And so it's basically like, as I said, almost exactly like if you were to ask a question to Google and then unleash an LLM on those results, it could give you an English response faster than you having to click through and read them. One of the benefits of this solution, especially up front when people are nervous about LLMs, is that in addition to the response that the LLM provides, you can also send back sources. So for instance, if you downloaded a bunch of content from web pages and that's where you got your content from, you could provide the links that it matched on the similarity search. So this is the information that the LLM used to give you your answer. And so you can provide sources with it so people can click on it and still trust or do a deeper dive into the information that the LLM used to answer your question. So that is a benefit. But yeah, I have to underscore the fact that this does not actually teach the LLM anything about your data. The LLM isn't learning here. It's just using a quick reference and then answering the question based on that quick reference. Mm-hmm. Yeah, that similarity search is what it's doing.
It's just like summarizing the context. If you ask it a question, you go get all the data associated with it, and providing that to the LLM, which is then, like you said, reading it and summarizing it and spitting it out in English language.
Yeah.
Like I can see our like standard operating procedures are in 100
So
PDFs.
SOPs is a common. I mean, I actually have a slide, not on here, but that's exactly the same slide that I shared with a company last week, and we'll be sharing with another more local company in 2 weeks. So, yes, standard operating procedures is a perfect use case for this type of thing. Because normally it takes someone looking through it, reading through it, and this can just bring it all together and give you an answer really quick. And so that's a perfect use case for this.
To clarify, do you have to have Databricks to do this?
No. I would recommend it,
Right.
but the platforms that you're probably looking at are Databricks, or building it out on an actual platform like Azure or AWS. AWS is fairly far behind right now. Azure is making a lot of progress very quickly, but Databricks makes it easier. As I said, on Databricks I could get it out to you in an afternoon. So yeah. All right. So this takes that last. And how much time do I have?
What did you want?
All right. So Databricks, or not Databricks, this concept takes things a little bit further. So it's the exact same architecture up top, right? But what we're doing here is we're creating sort of a feedback loop. One, we're capturing all the inferences, right? We store that off into a database. So now you have all your prompts, you have maybe all the source material that it looked up, and the actual answer that the LLM provided you. You give your users a means of sending back feedback. So you could do this all through like a correlation ID, like a conversation ID or something like that you set up with your chatbot. But the users, it could be as simple as a thumbs up, thumbs down. Hey, I like this response, I didn't like this response. It could be score it on a range of 1 to 10. What did you think of this response? It could be, if you don't like it, correct the response and submit the correction. If you've ever heard of RLHF, it's reinforcement learning through human feedback. It's something that OpenAI felt like was crucial to them being able to get to the place where they are with their models. There's a lot of information out there about how to do it. It's a couple of weird sort of ways, but a lot of times it really just comes down to fine-tuning on the human-provided response, and then that somewhat teaches the model how the human's expecting the response. Even if you just do thumbs up, thumbs down, you can provide feedback back to the model that trains it on maybe people like shorter answers than longer answers at this company, and so its shorter responses get more thumbs up than longer answers do. And over time, you could start to fine-tune a model on the good answers or the corrected answers, and it'll learn how to give you responses far faster than it'll learn the information behind it. But if you fine-tune enough, if you train it enough, it might start picking up on your domain information and everything as well, and so give better answers. So this is one of those things that I would say a more mature organization, they might first start with a RAG and then start adding things like this to be able to get even improved performance over time.
Now at this point, like Eric's question, you are retraining your...
This one we are retraining. Yeah, so to be able to do this, for longest time, OpenAI didn't allow you to fine-tune any of their ChatGPT models. Now they allow it for 3.5, and they're promising that they'll release it for 4. And so that's great. So you could do this on their SaaS models. What you would have to do this type of thing, just a few months ago, you would have to use an open source model to be able to fine tune it. Yeah, so this works well.
The features over there, embedded domain context in prompt, is that similar to topic modeling? Does this do topic modeling?
So the embedded domain context and prompt is referring to this RAG solution where you're looking up domain context and you're including it in the prompt. So you're embedding that domain information into the prompt. Okay. And then the LLM has that extra information in the prompt. So that's what that's referring to there. I don't know if I quite understood your question.
What I'm asking is, let's say I have like a set of comments, customer comments, and I need to create topics for each of it. Couple of customers said the service was bad, the other two said the product is great. Like, will it read those comments and give me topics? Does this architecture do that?
So what this architecture does is, with the prompt that comes in, it does a similarity search. So it returns records that are similar to those same embeddings, right? So it will pick up, like if you say wolf, it groups things like wolf, dog, and coyote, and so it might find something that talks about, or if you say good, it'll match on excellent, and things like that. So you'll get returns that are like that. You can also include metadata. So you have your vector column that it does similarity search on. You also have additional columns that you can include in that, and so that those additional columns could include like a score, or a category or something like that. You can either use those to filter on, or you can include those and then build out your prompt template so that you're including that information as part of the context that's being provided. Hey, this comment came with a 4-star rating, and this kind of thing. And so then the model would have context of that additional metadata that comes with it. Okay, all right. This is my favorite one to talk about, the agent architecture. The reason being because there's a lot of capabilities in this area. So I'll explain what's going on here. So this is using an LLM like a brain, and so even in these types of modes, it's one way. You know what actions you're going to take when. This is very much not one way. Any type of action can be taken with any kind of prompt. So what you do here is you actually provide the LLM with a list of tools that it has available to you, and you're not asking it for an answer, you're asking it how to get to the answer. So this is the sample that I provide. Maybe what you have is you have 2 tools, a business glossary and a database. And that could be a data warehouse or whatever that the agent has access to. And so the prompt might be, someone from the business side comes in and says, hey, what's our EBITDA for the current quarter? And the agent says, hey, these are the tools available to you. You have a business glossary, you have a database. These are the functions you can call. Like you can do a lookup on a term against the business glossary. You can look up what tables are available to you. You can get table definitions, and then you can execute SQL. Maybe those are the functions available to it on the database side. This is the question from the user. How do I answer this question? And so the LLM will come back and say, all right, first let's do a lookup on the business glossary for the term EBITDA. And so the agent then executes that function. It could be just like an API call. It says, define term EBITDA. That information comes back. And so maybe this now has a business definition. Maybe you have really good business glossaries. So you even include what sources that information can come from, what calculations are used to get to the answer. Maybe you even include information as to how it's built out for a year-end or a quarter-end type event, right? The agent then sends all that information back to the LLM. Hey, this is what you told me to do. This is the answer. And the LLM says, great, what tables are available to me? And then it goes to the database, and it comes back with a list of tables. All right, I think these 2 or 3 tables are going to be right. Maybe they're part of that calculation, whatever. Give me the definitions for those tables. And so it comes back with the rows, maybe some comments and things that are to help define what those are, not rows, but comes back with the column names and then comments that explain what those columns can be used for. The LLM uses all that context and then write a SQL statement, sends that SQL statement through, gets the response back, and now so it has all the data it needs. Now it provides an actual response to the user telling them this is what your EBITDA is for this quarter. It requires, one, really good data management. It requires an LLM that's got really good reasoning capabilities. ChatGPT 4 does a pretty good job with this kind of thing. I've gotten 3.5 to work occasionally. And you usually have to give it a really specific prompt to tell it what it needs to do and to how to facilitate it. GPT-4 usually is pretty foolproof at being able to execute. But this type of thing, to me, really shows what an LLM is capable of, and enabling an LLM to execute things outside of just its normal context, which is usually people use it to answer a question or to do a chatbot. This here gives it a lot of kind of capabilities. I've written, yep.
What's the technology behind the agent? Like, how is that agent created?
It's just a Python library. So I mean, it's just a dumb API tool, because all it does is receive the prompt, pass it to the LLM, receive the command from the LLM, execute the function with the arguments that the LLM gave it, gets back the response, feeds it back to the LLM. LLM then tells it to call another function. It does that. So OpenAI released a feature called functions that does make this architecture much easier to do, because you don't have to do any parsing of the response. So so OpenAI doesn't return a response, it returns a function call. And so what it's doing is it actually says, hey, you call this function and use these arguments. And so all the agent does in the background is call that function and uses those arguments. And so what it's providing to the LLM at runtime is these are the functions available, and these are the arguments, and these are the English description around it. And so I actually built a library that can receive any Python object, and it strips all the methods off of that object, uses the documentation that's provided with that object, and passes all that information. And so all I got to do is supply it with an object that has methods in it, and now the LLM can call any of those methods. And it works pretty well. I built one that can read and write files. And so I can have it read and write Python files and stuff, and so it can build an application itself. Once again, you're still working with that 4,000 token set. I wish I had the 32K, because then I could move a little bit faster on that kind of thing. But as long as everything that it's working with is under that 4,000 tokens, it can read a file, understand it, rewrite the file if there's a bug in it, and I tell it, hey, this part isn't working. That kind of thing, and it does a really good job of that.
Question.
Yep.
So if the prompt the user is giving requires some kind of Python computation, this agent is running the code for you by reading the documentations, and then source code will be
So you would have to give the agent like an executable or path to execute that code, right? And so like I have built one that, for instance, the LLM can generate Python code, submit that to the agent, and then what the agent has a parameter behind it that allows it to create a notebook in Databricks, put that code in that notebook, run that notebook, and then get the results from that and feed it back to the LLM. So as long as you provide it with a mechanism for executing that call, then yes. But I can't underscore enough how dumb the agent is. It just has the tools that you give it, and the LLM tells it specifically what functions to call and what arguments to pass into it. And so if you give it a function that can execute Python, then the LLM can either generate Python, or you could submit Python from the prompt, and the LLM will tell it to execute it through that function call, if that makes sense.
So you first need to provide the functions that it needs to know.
Yep.
So it doesn't automatically know what function it can use.
No, so what you are creating with this agent is you're saying, hey, you have a function called lookup term, And what it does in the background is it calls the business glossary and it passes through this argument that might be term, and then it gets the definition back from the business glossary, and all it does is return that result back to the LLM. And then you also might define, you have a function called list tables or list available tables, and maybe all it does is get you an array of strings of table names, you know. And then maybe you have another one that says get table definition, and you can input a table name, and it looks up that table definition. So then it returns your column names, their, you know, whether or not it's an integer or string or whatever, and maybe some comments or something that you've put into it as to what that column is used for, you know. On Databricks, we have something called Unity Catalog that allows you to add a lot of that additional context, and so I'm able to look that up and provide those comments back to it. You can also provide tags and stuff, so if you have a PII tag or something, you can include that in it, and you could add additional instructions that say, hey, don't query a PII column or something, and it would know not to do that. So yeah, it becomes pretty, you got to add all those individual tool sets, and you got to define them, and the agent has to provide them to the LLM. But once the LLM has context of that, the LLM knows how to call it, and then the agent will turn around and pass the information straight through. That is the last of that. I am going to see if I can get this working. As I said, the Hugging Face aspect of this was not working. Does everybody here know what Hugging Face is? So Hugging Face, you know, has risen to popularity on all this stuff, but I call it the GitHub of models. Really, these LLMs. There's a ton of LLMs out there, and they're bracketed in different ways. But one of the things you can do is you can create a space, and then you can upload an app. And so we have this app that basically serves as the UI layer. In the background in Databricks, we have a model serving endpoint. It's because I lost internet for a bit. And with that model serving endpoint, you have a URL, and you can initiate a command against that URL, pass through the prompt, and then it'll turn around and do the inference behind the scenes and then send that back. And in that model, what's actually happening, this is way too small. It's doing everything that we're describing here. So in Databricks GPU model serving, it's not just the LLM. In this situation, we're using Llama 2 13B, but it actually facilitates all this in the background. So it's doing the similarity search, it's stuffing a prompt template, and it's providing all that information to the LLM, and the LLM is returning the results. So let's see if this works. It doesn't. Okay. So it's something's going on this side, because I have the endpoint up and running, and who knows, we might even be able to see the inference value come through on it. But the idea here, and you can picture, I hate it when this doesn't work. It's like, it always works for me, except for like 2 times that I've ever tried to do it. And so right now it's not working. But you can come in here and you can say, you know, what do I do if I ingest arsenic? And in the background, and even we, right, the person who wrote this up, used the word trained. It is not actually trained. You know, it's just doing a similarity search. So we downloaded chemical sheets, and we parse those out and we put them into a vector database. This one's using FAIS or FAIS in the background, which is Facebook's vector database. And then at runtime, we're doing a similarity search based on the question that's asked. And then it's providing all that information to Llama 2, which then gives us our answer. And as we see, we're getting an error in response. The great thing that I like to show here is that it can also provide sources, so it shows you what PDF documents it actually found and which ones it returned. I do have code to show, and I know this is a more technical crowd, so I'm always happy to share code. this is usually the most critical aspect of anything that you would do. It's creating the embeddings. And so what this is building out that vector database. So what you'd see here is they have a directory where all those files live. This is information to sort of extract metadata out of those PDF documents. So all the PDF documents are out there. This is the model that they're using. And I feel bad, Murphy. I'm leaving you like no time. This is the model that they're using for the vector database. They're providing a directory to persist the vector database to. All this is sort of created at runtime, and it's almost like if you think of it like an Access database, it's able to just say, hey, create it in that directory. And then this is the directory where the PDF documents live. And what it does is it just iterates through all those PDF documents that exist out there. It parses them apart, extracts metadata, which is really just the chemical name that it's extracting from it. We have our chunk size and our chunk overlap. So you have natural libraries out there that will break these large texts up into chunks. And so the chunk size will tell you like how many words to use, and then it also overlaps so that you don't maybe cut off in the middle of an important sentence. You'll have one chunk that does, and then the next chunk will have some overlap, so it'll include that information. And these are usually configs that you'll play with to figure out, hey, what's the right size, what's the right overlap to help you figure out, what kind of performance you get with it. So it's one of those sort of incremental things that you can work on. So we split all that up. And then what we're doing is we're actually writing that out. So as you can see here, if the vector database doesn't exist, then it creates it from scratch. It's passing in that page information, so all the individual content. It's passing in the embeddings that were generated. And then it's passing in metadata and the primary key that you're going to use. And then if it already exists, then it's just adding new records to the database. And you're done. So as you see, this one notebook right here, we ingested a whole folder of PDF documents, broke them up into their various chunks, and then created a vector database with embeddings that were generated from this model on Hugging Face. And so if you wanted to use a different model, you just have to change the model name here, and it'll download that model. One of the things you got to be aware of is, yep.
I have a question.
Yeah.
You're ingesting PDF. Let's say that the PDF file is a table. First, you need to identify what a table is. What if those PDFs all have different formats of tables?
So you're talking about tables in the PDF?
Yes.
Yeah. So that is where the devil can be in the details, depending on how you're ingesting it in. I would recommend looking at it, seeing if you can identify that structured data that's in there. It's usually easier to do if it's an HTML form. So if someone's downloading a web page, you can use Beautiful Soup to sort of parse that kind of information out. So if you have context like that you got to worry about, one, you can either try to hope that there's a chunk that has all that information in it, because the LLM is actually pretty good at understanding structures, especially if there's some sort of separator in there, and so it can understand, okay, this column maps to that value, and so that's the column name for it. If there isn't that, then you do need to worry about it. So I would look at the actual text that the LLM is going to be looking at and see if you can decipher it. And if you can decipher it, chances are the LLM can decipher it, because you can do things just like pipe delimited records and stuff, and the LLM is pretty good at understanding what you're trying to feed it from a structured format perspective.
PDF parsing is when you're trying to, you don't have an HTML, you have a generated PDF file and a table in it. It recognizes some lines if there's a line breaks in it, but some tables are just blank, just rows.
And so yeah, if you just have text with spaces,
yes.
and so that's going to be more difficult to mess with.
Are you trying to do computer vision, or are you actually trying to extract the tables? So there should be stuff out there that would just extract the text and not the...
Extract, but it doesn't preserve the table format.
Yeah.
Not necessarily.
So it just kind of runs it all again.
So that...
Yes.
Yeah, that does become a separate challenge.
Okay.
Because you do need to get into a text format that you want the LLM to be able to receive and use. But it is a challenge that some people, depending on your format and what you're able to get it out as, you can have issues with.
I would say like data science is like 98% of just data engineering, just munging through all data, and then 2% actually fun stuff.
Yeah. And so I have another solution accelerator, just not this one, but we download, as I said, our Spark documentation, and it's amazing how much cleaner beautiful soup is against HTML than just trying to ingest PDF documents, which can come in a variety of ways. I've ingested PDF documents that really comes in like a JSON and has like a page number and all this additional metadata for that page, and then it has the text. And so you gotta parse that JSON to be able to get the information that you're going for. So anyway.
And you said for your demo you're using Dolly or
Llama 13B. That's the model behind the scenes.
That's what you're hosting in the serverless?
Yeah, so we're hosting that in model serving. And so if you're interested, what we're able to host it on, so we have GPU model serving, which means we can host it on GPUs. These things have to require GPUs, but that Llama 2 model, for instance, is being run on a single A10. So if you're familiar with NVIDIA cards, N10 is smaller than A100. I have used Code Llama 13B, and I needed 4 A10s for that one for it to work.
So what would it cost per hour?
So this, for instance, here is 24 DBUs. We charge 7 cents a DBU for model serving. So do that math. That's what a dollar, $1.80. I don't know. My math is failing me right now. But something of that nature per hour. And so multiply that times 24. Not extremely expensive, not super cheap, but that's what you do. And this supports up to 4 concurrent requests.
So this is dedicated. This is a dedicated cluster. Will it host in serverless serving?
So this is our serverless. Because of the nature of the GPU and stuff, we can't scale this to 0.
Okay.
And so that they say it's coming. So in the next couple of months, you might see scale to 0. I'm very curious what they're going to do with that wake up, because it's probably not going to wake up in 3 seconds.
Yeah.
And so I am curious to see what that lag is from the first request to when it's actually up. But because of that, right now it's on 24/7 if you're using GPUs.
So it scales to 1 as the minimum, but will it scale up? Or is
Yeah, it'll scale up. So one node supports 4 concurrent requests. If we started hitting this with a lot, it would scale up from there. Okay. And you pay for capacity. So that's it. If you added another node, it jumps to 48 DBUs per hour. And so as it scales and then scales back down, your cost will change. But this would be sort of like your baseline cost for prototyping and things like that. Now, if you were to use OpenAI, go ahead.
Can you use your query input there to try it out?
I can, if I knew the right format. I probably should have experience working with this. I always build it through notebooks and stuff. And it looks like, I wonder if I could just build it out right here and do it. But I won't do that in real time. Yeah, the demo demons will get me. But yeah, so you can do things like that where you can just provide it and pass it through. What I normally do is I'd copy and paste this into a notebook and then I'd modify it and submit the request that way through a notebook. But yeah, so I wish I had been IMing with someone who was going to look at it, and I guess they either didn't get a chance to look at it or didn't get it off. He's the one that knows a lot more about the Hugging Face side than I do. So I was looking to him to sort of fix that part. But I have other code, like agent architecture type stuff, and so maybe that, to actually have something that works, maybe that would be nice. It's on a different platform. But but I also might want to give you time to do your thing.
No, I'll have to save it for next time. We gotta.
Yeah, got
we
10
have
minutes.
this till 1.
Yeah. So I'll at least, I don't know. I won't start it all up and run it, but I can at least walk you guys through a notebook that does it. And I'm a little proud of this at this moment. You know, when you build something, you don't really think that it's going to amount to anything. And then I showed it to some specialists at our company, and now they're using this in stuff they're building out for customers. And so it's pretty cool to have something that you just work on the weekend that that now is actually going to get rolled out stuff for people. So you know, it makes you feel a little good when something like that happens. So like this would be a good little notebook. Runs it, but the way that it works, it's just a library. As I said, so the way this works is I have my chatbot library, and then I have my tool set library. So this is Unity Catalog is what I'm calling. It gives me access to Unity Catalog, 3 main functions, lists the tables, give me a table definition, and then execute this SQL. So the prompt, you're an expert data analyst. A user will request information, and you'll use the functions provided to you to gather the data you need. And so that's the instruction set that I provide to it. This is the catalog, and that's the schema that I'm going against. Somebody built a data warehouse, and I'm using it. Poor Justin. And then what I'm doing is I'm passing in that tool set to the chatbot. I'm telling it to use GPT-4. And then I save the conversation out, and so that's what that is. But it asks a question, who is my top customer? It calls list tables, gets the table listing. It then says, okay, these are the 2 tables that I think would be important, so give me table definitions for that. And then it generates a SQL statement based on the information that it received. And it gets the answers. And then the answer that it provides to me is your top customer is Tailspin Toys with a total sale of $438,000. And I said, how about the customer who made the most purchases? Well, it's still, because this is a chat application. Yep.
The top sales that you showed over there,
Mm-hmm.
you just asked who is my top customer? How does it understand my top customer is it based on total sales, or is it based on revenue, or other attributes?
It's a very good question, right? So I actually give it very specific ways to ask me questions. Sometimes it asks me a question. Most of the time it does not. Most of the time it goes, well, I think I can figure this out for you. That's one of the negatives, I would say, of 4.0 is that it's a little bit creative like that. Now, one thing I can play around with is turning down the temperature. I'm not sure if people are aware of the temperature parameter, but if you lower the temperature, then it tries to be more precise. If you increase the temperature, it tries to be more creative. And so I could try lowering the temperature and see if it asks me more questions. I like that question. That's exactly what I want it to ask me. I want it to be like a really good data analyst that goes, you're not tricking me with this top customer nonsense. I need to know what that is. But right now, in this situation, in this run that I did, it made an assumption. So you'll see me try to correct it, right? Well, how about the customer who made the most purchases, not just the most total sales? Because it's a chat, it remembers the history, so all it does is generate a new SQL statement, and it tells me the customer who made the most purchases is Bhavan Rani with a total of 457 purchases. To me, that tells me that guy had the most orders, right, or most lines. That's not really a top customer. And so then I ask a more precise question, is that the customer who bought the most items? Once again, it generates a new query, and then it answers, no, the customer who bought the most items is this person with a total of 18,965 items that they purchased. So I'm taking it through that path. Like you said, I wish it would sort of go, hey, I see a few different ways that I can answer this question, which way would you like to go? But at least I can still steer it down there. I helped a customer implement this on their system. What was really fun is that it even eventually started correcting their spelling a little bit, because they would misspell Corpus Christi, and it understood what they were saying, and so it corrected it when it wrote the query. They were using very choppy English with it, and it was figuring it out. So it is really impressive what some of these models can do with all that. But anyway, that is where I will leave things, sort of the art of the possible. As you see, I've just wrapped this in a notebook, but you could build a UI that sits on top of it, and that's what our specialists are doing with it.
Is this open,
yeah.
or is it?
I do have it on GitHub. I have not made it open, but I would be willing to share it with anybody here.
I didn't know if Databricks owned it.
It's mine. Yeah.
Okay, cool.
Yeah. So.
Yeah, and this is the agent model, right?
Yeah, this is the agent type architecture.
Cool. Well, thanks, Robert.
Okay.
Will your video be posted somewhere?
I believe so.
Yeah, I think we're gonna try to put all this together and put it on YouTube or something. Thanks.
You're welcome.
I'm gonna save mine for next time, so you don't have to wait around for it. So yeah, thanks for coming. One more drinks, pizza, if you want to grab it.